Welcome back to Physics 101. Today we have a special guest with us. Please tell us your name and what are some of the experiments you worked on.
Hello everybody, my name is James Frank and I worked alongside my colleague Frank-Hurtz on a groundbreaking physics experiment that we done in 1914, which is now famously known as the Frank-Hurtz experiment.
Oh, okay. So what were you guys trying to find?
We were investigating actually how electrons interact with atoms, specifically whether atoms absorb energy continuously or in discrete amounts. So at this time, it was a major question. Classical physics couldn't fully explain atomic behavior. So we aimed to test Niels Bohr's quantum theory, which proposed that electrons could only occupy certain quantized energy levels in atoms.
Oh, okay, that makes sense. Where did the project or the experiment occur?
So our work actually took place in the University of Berlin in Germany, in a well-equipped research lab that supported our high-precision electron tube experiments.
Yeah, so what was some of the significant events that were happening around the world at this time?
So 1914, of course, World War I was starting up, and tensions was high across Europe, and soon after our publication, much of the continent was drawn into conflict. Even though the whole world was at war, we still got work done, and particularly in quantum theory, which continued to advance, in the background of all the world war that was going on at the time.
Yeah, and you and Mr. Gustavus, I'm pretty sure is who else worked in this experiment with you?
So me and him was the main ones, but we built on the work that was previously done by J.J. Thomson, who discovered the electron, and Niels Bohr, whose atomic model inspired our theoretical framework. Many others in the physics community were watching our work closely as they sought evidence to support quantum ideas.
So it sounds like you had a pretty good team, but what was your role in the project?
So my major role was helping to design the experiment and interpret the results. My background in physics allowed me to recognize that the observed drops in electrons current was evidence that electrons were losing energy by exciting mercury atoms, only at specific energies. This was a direct validation of Bohr's model.
Okay, that makes sense. What impact did your project have on the physics community?
So my impact was that we was one of the first directed experimental confirmations of quantum theory. It showed that atoms can only absorb specific amounts of energy, supporting the idea of quantized energy levels. This experiment earned us the Nobel Peace Prize in physics in 1925 and became a foundational piece of evidence for modern quantum physics.
Okay, I got one last question for you and I'll let you go. So, if you were able to do this project today with today's technology, what would you do differently?
So, for example, high vacuum electron tubes, computer modeling, laser spectroscopy, we could have collected far more precise data and explored other elements beyond mercury. We could also be able to automate the measurements and analyze quantum interactions in real time.
Well, thank you for coming on to the show with